Hello, so today we move on to the next part. This is still under graphs, sketching of graphs. Okay, here today we are going to determine the number of solutions to a trigonometric equation. Okay, but we are not going to use solving method. We're just going to use graphs to look and to see how many uh, points of intersection to determine the number of solutions these two equations will have. Okay, so we are given a question like this. Okay, sketch the graphs of y equals to 3 cos 2x and y equals to x minus 1. For x, okay, it's in this domain, the range of 0 to 2 pi. Okay, hence find the number of solutions for the equation. Okay, now this is your equation given. Okay, now when you look at this equation, okay, this equation is actually a combination of this and this. So we notice there is 3 cos 2x, which is here, and okay, and there's a 1 here equals to x. So meaning what you can do is, now let's say we break this up. So this is cos 2x equals to x minus 1. So if you notice, this is actually the first equation that you're supposed to draw, and this part here is actually the second equation. Okay, so what we're trying to say, or what we are trying to do, is we're actually trying to solve this but using graph method. Okay, so we'll draw this first, sketch this first. Y equals to 3 cos 2x. Okay, now if you still remember, the first value in front of the function will actually give you the amplitude of the graph. This will actually give you the cycle. Okay, the coefficient of x will actually give you the cycle, how many cycles of the graph. Okay, and there's one more value where it's actually, it tells you how many units shifted up or down. In this case, it is not stated. Okay, all right, so we sketch this first. Okay, now your amplitude is 3 and -3. So the graph is actually inside this range. So it's a graph, of course, in 2 cycles. Okay, so it'll be something like that. And so that's your 2 pi. So your pi will be here. Okay, so my here. Alright, so that's my graph, and of course this is 0. Okay, and then we go for this y equals to x minus 1. Now this looks like a straight line. From here you actually know this is your y-intercept. So I've got one coordinate for this straight line being 0, -1. Okay, so 0, -1 will be, let's say, around here. Okay, let's say that's my first coordinate that I have. Okay, we need one more, so probably I'll use the value of pi. Yeah, so let x to become pi, so pi minus 1. This in place of x, we substitute pi. So what we get is pi is actually 3.142. So minus 1 is 2.142. Okay, so again, if we split this up, 2.142. Okay, estimated, let's say it's around here. All right, and let's say we connect. Okay, all right, so that means this is my line of y equals to x minus 1, and this is my graph of y equals to 3 cos 2x. Okay, so now based on this, you can actually see that there are intersections between the straight line and the graph itself. So how many intersections do we have? It's one here, one here, one here. Okay, so meaning in this case, based on the graph, there's 1, 2, 3. So that means my number of solutions will be 3. Okay, so that's how we do that. Okay, let's look at one more question. Okay, for this question, now the question again, something similar. Sketch the graph of y equals, okay, there's some modulus here, modulus 3 sine x, and y equals to half x for this domain. Okay, x is between 0 and 2 pi. Find the number of solutions for this equation. Okay, so this is my first graph. This is my second graph. Okay, now let's take this down. Sine x. Okay, minus x equals to 0. So 6 sine x minus x. This will be 6 sine x equals, I bring this over here. Okay, so that means, let's say if I leave a 3 here, sine x, so it's actually 3 times 2. So this comes down as x over 2. Okay, so that means now this one here is my first equation. This is actually my second equation. Okay, all right. Okay, so how do I do this, or how do we do this? Okay, first thing, let's look at our sine x. So if you still remember the function of sine, okay, the graph is something like this. So here pi, this is 2 pi, this is 0 pi here. Okay, so if it's a modulus, means as we have seen before, this thing does not exit, it's actually reflected up, so means the graph becomes like this, so we don't have this here. Okay, so that is when it's modulus. Okay, and we check, first thing first, my amplitude, that's my amplitude. Okay, cycle here, coefficient of x is 1, so it's only one cycle. Alright, so the graph is going to be something like this. Okay, that's pi, 0, and this is 2 pi. Okay, alright, next we go for the second graph, which is y equals to half x. So y equals to half x. Of course, first thing you substitute when x is 0. X is 0, y will also be 0. So my first coordinate is 0, 0, which is here. Okay, we need one more. Okay, let's say I go for pi. So let x to become pi. So y is actually x over 2, right? So it's 1 over 2 pi. So we'll get about, pi is 3.142. So when we divide it by 2, you get 1.571. So my second coordinate is actually pi, 1.571. Okay, so now let's assume here 3, that's my amplitude. So we need, okay, that's my 3 parts. So I need pi and 1.57, so it's somewhere here. Okay, alright. Okay, so my first one is 0, 0. This one is here. Okay, we'll connect that. So this is the line of y equals to half x. And this one here is y equals to 3 sine x. Okay, so how many solutions are there? 1, 2, 3, 4 solutions. Okay, so we are not required to find the value of it, we just want to know the number. So therefore the number of solutions equals to 4. Okay, so that's the answer. Thank you.